All right, I've got a temperature gauge here, and now we have a temperature for it. It's 26.6 degrees Celsius here in this room, if you were here in this room with us. I also have some room temperature water. I have my coffee cup calorimeter, and I have ice that is melting, and that is on purpose. I want my ice to be in the melting stage. So what we're going to do first is we're going to start out with a set amount of water. How much water should I use? It really doesn't matter. Um, I like to throw in about 75 milliliters ish. But either way, I'm gonna get the mass of it, so I don't really care. So someone needs to write. Oh, stop it! Look at that. The mass of the water, the initial mass, or I'm sorry, the mass of the water is 80.01 grams. All right. And you probably can guess I'm going to need a temperature of that water. So the water does appear to be a little bit cooler than my room temperature. Maybe it's because I'm standing over here by a window. Don't write down that mass because that would be, of course, the mass of the thermometer, which really doesn't matter at all. Then I've got this ice. All right. So temperature of my water right now is 24.6, 24.5. It's kind of going down here. Maybe I should spin this around and see. It is. Now this ice is not super frozen from the freezer, which is on purpose because what I don't want is to calculate the amount of energy it takes to heat the ice. I want to know how much energy it takes to melt the ice. What I'm going to do is I'm going to go ahead and drop this ice in. How much ice? It really doesn't matter. There you go. About 3 is good. And I can go ahead and start kind of spinning around. Literally, all I'm doing is melting this ice in the room temperature water. Now, this is not too difficult. The temperature is going down, right? And if you can see there, there's still a little bit of ice left. I'm gonna do this until my ice is all gone. And I've hit basically my lowest temperature. And it is, it's still going. Maybe we could look at our graph now. Ooh, look at that. It's definitely going down, starting to level off here. And I can hear that the ice is pretty much melted at this point. So, except there might be some little guys left. So I'm looking for this lowest temperature it goes before it starts to kind of go back up. Oh, wow. Very exciting. You think that's done? Oh. It looks like all the ice is melted at this point. All right. I think that that's probably as low as we're going to go. That 8.9, because we're kind of sitting there and it looks like all the ice is melted. And if I had to predict, it's probably going to start going up. So now what I want to do is I want to find out how much ice I used to melt to that 8.9. All right. So I'm going to put it back on the scale. And you can go ahead and write down that number, 97.12. Or 13, somewhere in between there. That is the mass of my water plus my melted ice. So you should have 4 values at this point. We should have the mass of the water and the ice, the initial temperature, and then the temperature after the ice melted. And with those 4 things, you can experimentally determine the heat of fusion of ice.